Okay, so this one wants you to draw a Hayworth projection for 1,2-dimethyl cyclohexane and think about the maximum number of stereoisomers. Now, the maximum number of stereoisomers are 2 to the n, where n is the number of stereocenters. And in this case, we have 2 stereocenters, so there should be a total possible of 4. And so let's draw a Hayworth projection is when you take that ring and you use the wedge and dash convention to draw the ring sort of on its side so that you've taken a flat projection and you kind of tilt it at the reader. So you have a flat ring and you tilt it up a little bit at the reader so they can see a front to back version of the ring. And so in order to do that, I said I'm going to need 4. So I've got an iPad. So this is going to be really handy for me because I'm going to have to redraw another one, and I'm going to have to redraw another one, and I'm going to have to redraw another one. And so that was really fast on the iPad. And so totally helpful there. And now what it wants me to do is it wants me to try to draw all 4 versions. And so with a Hayworth projection, what I'm going to do is I'm going to draw the bonds that have the CH3s. So one version is where I have one up and one down. That would be one stereo possibility. And then the other version would be where the other one is up and I swap them. And so these may seem like they're the same molecule, but they're not. Let's see if I can do this. If I were to rotate it like this, you see that the one on the left isn't up, right? So I can't just rotate it so that it's the same molecule. So I can't just rotate this molecule to make it look like this, because when I rotate it, it doesn't look like that. And so the iPad is really helpful for showing students this, right? So let me rotate it. It's not. The down one is still on the right. Okay, what are the other possibilities though? I have both of them down, and I have both of them up. That's the other possibility. So what do we end up with here? Do we have the maximum number of stereoisomers? It turns out we don't. Let's take a look, right? So if I can rotate one to make it into the other one, then they're not different. And so here's how these two structures that would be the cis version isn't really 2 different stereoisomers. The cis version is the same. And the reason it's the same is because it's actually a meso compound. Here's a plane of symmetry. And this plane of symmetry means these 2 guys are the same. And so there's actually only 3 stereo isomers possible, or 3 unique stereoisomers from the 4 possible. Okay.